Let's talk about the modeling concepts, and these are very important as far as data modeling goes. And these modeling concepts are used in both ER diagrams and dimensional modeling, definitely a lot in ER diagrams. The first one is normalization. So what is normalization? So it is a data organization technique which is used to remove redundancy or data duplication. Now the question is, why to remove redundancy? So if I have to answer that, I'll have to go back multiple decades. RDBMS as a concept was introduced long back. And back then, the storage used to be very costly. So the purpose of storing data is to remove duplicates or remove redundancy. So that's when normalization was introduced to remove data duplication or remove redundancy to reduce the storage size. Because obviously, if you have a lot of duplicate data, it would need more storage, which would lead to more cost. So to reduce cost in an optimized way, the best way is to or was to remove the duplicates. So normalization technique was introduced to remove the redundancy. But by removing the redundancy or data duplication, it should not challenge the integration of the data. So that's why it's more of a data organization technique today rather than removing duplicates. And it is used to define the data integrity also by optimizing the storage and removing redundancy. And the technology and the way that you do normalization are called normal forms. So what we do is that if you have a set of data, we make sure that the data follows the normal forms that I'm going to discuss. Again, normalization is a data organization technique which is used to remove redundancy or duplicates by keeping the data integrity intact. And these are the various normal forms. We have first normal form or 1NF, second normal form, third normal form. We have fourth and fifth normal form also. And there's something called Boyce-Codd normal form or BCNF. Typically, in most of the cases, we tend to be within third normal form. We do not go beyond third normal form unless it is absolutely needed. So that's what I'm going to talk about. The first one was, of course, would be the first normal form. And this is the data that would use to come to the normal forms, or this data would be used to basically create entities, remove duplicates, and do the normalization. So we have order ID, order date, delivery date, description, order price, order items, customer ID, customer name, customer date of birth, customer email, and customer address. So if you see here, we have this order ID or this is the order date. Also, this is the delivery date. And in the description, we have iPhone, Samsung Galaxy. In the order price, we have two prices. One is for the iPhone and the other one is for the Samsung Galaxy. Then you have order items, the customer ID, and followed by the customer details. In the second one, we have three descriptions: Lenovo, Boat Electronics, and IFB. And we have order price for all three. Similarly, in the third one, we have order ID, order date, delivery date, and there's only one item, it seems, or one price, order items, the customer who ordered, and the customer details. So this is the data, and what we have to do is that we'll have to use this data, or you have to use this sample data and go through first normal, second normal, and third normal form and create entities, attributes, relationships, etc. using these normal forms. But first of all, we have to know what these normal forms are. So if you use the normal forms, if you try to put the data in these normal forms, essentially your data modeling would be done. So first normal form says that we'll have to define the possible primary keys, also known as candidate keys. So that is the first step of the first normal form. And you already know what primary keys are. Primary keys are used to uniquely identify a row. Correct. So we have this order ID and we have order date. We have customer ID, customer date, etc. So what would be the possible primary key? It can be the case that order ID is the possible primary key and customer ID is also another possible primary key. But we know that a single customer can give multiple orders. So customer ID would not be unique in future. So it does not make sense to put customer ID or use customer ID as a primary key. So as of now, the candidate or the possible primary key is only order ID and maybe order date also. Seems like order ID would be unique throughout. So I'll use order ID as the possible primary key. So I've used only one column as the possible primary key or called candidate keys. I can use multiple columns also. So based on that, there are two types of primary keys. One is simple primary key, which contains only one attribute or one column, and composite primary key, which contains two or more attributes. It's not one, it contains two or more attributes. So this is the first step, and we have defined or we have established the fact that order ID is a possible primary key or order ID is the candidate key. So that is the first step. The second step is a single column cannot have multiple values, and this is called repeating group in technical term. So to be in first normal form, we have to follow this statement that a single column cannot have multiple values or a single column cannot have repeating groups. And here we see that there are columns, two columns actually, which have multiple values or repeating groups. Description has multiple values like iPhone and Samsung Galaxy, Lenovo Boat IFB, and order price also has multiple values. So we'll have to break it down. We'll have to use multiple rows for these repeating groups. So we'll have to put them in their own rows, and that process is called decomposition. So in first normal form, what we have to do, we'll have to make sure that we have a list of candidate keys. It can be one or more than one. So in our case, at least as of now, it is one. Then the most important one is that a single column cannot have multiple values or single column cannot have repeating groups, which we have in this particular data. So we'll have to decompose this data and use multiple rows to keep those values. How do we do that? Again, we have this same table, and I'll break this single row into two rows because we have two values. This row would be broken down into three rows because these have three values, and the third row will not be broken down further. So this is how it would look like. So order ID, order date. Now in description, if you see, you have only one value iPhone and you have only one price, and accordingly we have changed the order items also because obviously this is one item and all the other values are repeated. So customer ID has been repeated, customer name has been repeated. Same is the case with date of birth, email and address. And not only that, order ID, order date and delivery date have also been repeated. Then for the second row, as we have three values, we have broken them in three rows. So the first row contains Lenovo with its price, then we have Boat Electronics with its price, then IFB with its price. But of course we have repetition for all the other columns. For the third row, we are not doing any decomposition because it does not have. But essentially what it means that when we get the data in raw form, we can have multiple values for description and order price. So it does not conform to first normal form, and to convert this table or this data into first normal form, we have broken them into pieces. The rows have been broken them into pieces based on the values on the columns, and in this case we have considered description and order price because these two have multiple values. Of course, we have repetition. Now that is not correct. So the purpose of normalization is to remove duplicates or remove data redundancy so that storage is optimized, but at the same time keeping the data integrity right. Which means first normal form is not correct for that matter. Now one more thing that you see here is that now order ID is repeating, right? So we have multiple rows with the same order ID. So in this case, we cannot use order ID as the primary key because it is not unique anymore. So we'll have to use composite primary key. So we can select any other column, the combination of which would be primary or unique rather. So order date is not falling in that category. Same is the case with delivery date. Description is, so order ID and description are unique. So if we combine order ID and description, it is unique than the second row. Prices also fall in that category, but obviously price is something that you should not ever put in a key. And all the others are anyway repeating. So it seems like that order ID and description can be the new primary key. and it becomes a composite primary key. So now after this particular exercise, we know that this table is in first normal form and the primary key is order ID plus description, which is a composite primary key. It's not a simple primary key. So now we'll move to the next one, and what we'll do is, as the table is in first normal form and we have repeating values or we have duplicates, we'll go to the next normal form, which is the second normal form. And what does second normal form say? The first thing is that the table has to be in first normal form, which it is. So we have done the decomposition and the table is in first normal form. Then the second statement of second normal form is that the non-key attributes should be fully dependent on the primary key candidates. Alright. So what are non-key attributes? So non-key attributes are the columns which are not part of candidate key. So in our case, the candidate key is order ID plus description. That's what we have thought of being the primary key. So the non-key attributes would be order date, delivery date, order price, order items, customer ID, customer name, date of birth, customer email, and customer address. These all are non-key attributes except for order ID and description, which are the candidate keys. For becoming a primary key, all the other columns are non-key attributes. So what it says that all the non-key attributes should be fully dependent on primary key candidate. So now what we'll do is that we'll do an exercise wherein we will make sure that this table is in second normal form. If not, then we'll have to do certain other things. What second normal form says that the non-key attribute should be fully dependent on the primary key or primary key candidates. In our case, order ID and description. So all the non-key attributes should be dependent on order ID and description. So let's take order date first. So order date is definitely dependent on order ID and the description also, because description is part of this particular order. This is green because order date is dependent on both order ID and description. Same is the case with delivery date, because delivery date is also tied with order ID and description. Now I will not talk about description because description by itself is a candidate key. It's part of the primary key. What about order price? Order price is definitely dependent on description because the order price is based on the item, and this is iPhone. The price $900 is for Galaxy and so on and so forth. But is it dependent on order ID? The answer is no, because we can have another order ID with iPhone in that order and the price would be same. So it seems like that order price is not dependent on the primary key completely, although it is dependent on partial candidate key, but that is not what second normal form says. It has to be dependent on both order ID plus description. So this particular table is not in second normal form because this column is deviating from the definition. What about order items? Again, it is not dependent on the order ID per se because the item is dependent on description. So we have one description, one item. Even if we remove the item column, it would be completely fine because you can find out the number of items. So it is definitely not dependent on order ID plus description. What about customer ID? Customer ID, is it dependent on order ID and description? I think so, because we need to know which customer has placed this order with this description. We need to know that. So it seems like customer ID is dependent on order ID and order description, because we need to know, as I said, which customer has placed this order. So what about customer name? Customer name is actually not dependent on the order ID, but it is completely dependent on customer ID, which is a non-key attribute. So this defies the definition. Same as customer date of birth, customer email, and customer address, because all of them are dependent on a non-key attribute, which is customer ID. So they are not conforming to the second normal form definition. They are not falling in place as per the definition of second normal form, which says the non-key attribute should be fully dependent on primary key candidates. But these are actually dependent on another non-key attribute. Order price and order items are dependent on a partial primary key, not the full primary key. So what do we have to do? We'll have to break this table into multiple tables so that all the tables are in second normal form. Let's go ahead and do that. So we know that this is our data, this is our table which is in first normal form. So what will I do? Let's take the order price and order items. Let's break these because they are related to the item description or order description rather. So order table, it seems like, would contain order ID, order date, delivery date, description and customer ID, because now if you take these columns and create a new table, order date, delivery date, order items and customer ID, all of them would be fully dependent on the order ID and order description. So order description is not there, just hold on for a second. And I have also put order items. To be honest, I need not had to put order items here. I can completely remove order items, because if we just use an order or use the order ID, I can see that there are two items. But again, let's keep it. And I'll break the description and price in a different table. So we have description and order price, and I have created an item ID. So which are incremental number in chronological order, and this item ID has been placed here. Right, so I have not put the description. So instead of description, I have put item ID, because that makes more business sense, that description does not define the entity really well. So item ID makes more sense. So now I put item ID here. Now in this case, order ID and item ID would be the primary key. For this table, item ID would be the primary key. So now let's go ahead and see whether they follow the second normal form definition or not. So the non-key attributes should be completely dependent on the primary key. So we have order ID and item ID as the primary key. Order date, definitely it follows. Delivery date, yes. Order items, this is a redundant column actually, we do not even need that. But I have put it here because we had this data. Customer ID, yes, it follows order ID and item ID because we need to know that information. So now this table, we will call it as orders table, is in second normal form. What about the other table? So order price is completely dependent on item ID because item ID is the primary key now, not the description. And description, again, it was already a primary key. So instead of description, we are using item ID. So description also is completely dependent on item ID. So this table is also in second normal form. Okay, so now we'll call this as items table. So both orders table and items table are in second normal form. Now one more thing is that how do you relate? How do you find out what is the order price? What is the order description? So that's where relation comes into picture. And we define relationships using foreign key. And which columns relate these two tables, or which column relates these two tables? Item ID in the items table and item ID in the orders table actually relate these two tables. So item ID in orders table would be the foreign key and item ID in items table would be the primary key. So we'll have to define foreign key in the orders table to relate these two. So now we can get the item ID and find out the description and the price. So this becomes the parent table and this becomes the child table. Okay, and we have defined the relationship also. Now we have one more table which is the customers. So we'll have to remove customers also. So we have done the similar thing here. What we have done, we have put customer ID, name, date of birth, email address, and we have only 3 rows here, right? And similarly, just like in the previous example, this is the customer table. And we'll have to relate these two, because what if we want to find out the detail of the customer who has placed these orders? So we'll have to find out a column which will relate these two tables, and it should be relatively easy. Customer ID is the column in both the tables which can relate them. So we'll have to define customer ID as the foreign key in orders table, and customer ID should be the primary key in customers table. So this two columns define the relationship. So this is the child table and this is the parent table. Now one more thing is that let's see whether the customers table also is in second normal form or not, because we'll have to make sure that all the tables are in second normal form. And this table, as you already know, is in 2NF. What about this one? So this is the primary key, and these are all non-key attributes. So name is definitely dependent on ID. Same is the case with date of birth, email, and address. All these belong to this customer ID only. So customers table is also in second normal form. So now this particular table that we had used, which was in first normal form, we have broken down this table into 3 tables, and all the 3 tables are in second normal form. So let's repeat. All the tables, as I said, are in second normal form with some additional stuff. Orders table has primary key as order ID and item ID, and it has foreign keys as customer ID and item ID. Why customer ID and item ID? Because we have to relate the orders table with the items table and customers table. In items table, the primary key is item ID, and in customers table, the primary key is customer ID. So all the 3 tables are in second normal form. So now we'll go to the third normal form, and this would be the last one because we'll not go further to fourth and fifth. Most of the cases will not need that. If you are interested, definitely you can read about it. So after knowing first, second and third normal form, it should be relatively easy for you to understand fourth and fifth, and BCNF also, which is Boycott normal form. Anyway, let's talk about the third normal form. So the table should be in 1NF and 2NF, which they are. We have 3 tables now. And the non-key attribute should not depend on any other non-key attribute. That is something which is important. So in second normal form, we say that the non-key attribute should be completely dependent on the primary key. And in third normal form, we say that any non-key attribute should not be dependent on any other non-key attribute. So these are the tables, and all the 3 tables are actually in third normal form also, because there's no non-key attribute that is dependent on any other non-key attribute. And let's look at all the tables. So in case of order table, we have order date, delivery date, order items, and customer ID. So these are the non-key attributes. We'll not talk about order ID and or item ID at all because these are key attributes. So let's see if order date is dependent on either delivery date or order items or customer ID. The answer is no. It is not dependent on any one of these. What about delivery date? Again, same. It is not dependent on either order date or items or customer ID. It is dependent on the order ID. Same is the case with order items. Order items is dependent on order ID, and this is a non-significant column, and we can completely remove it also. And then customer ID is also not dependent on anything else apart from order ID. This is in third normal form. And you go ahead and do it for the other tables. So all the 3 are in third normal form. So what will I do? I'll expand one of the tables. So let me expand the customer table. So if you see the customer table, I have added a few more columns like country, state, and date of birth, MMDD. Now let's talk about these individual columns. The first one is country, and we are dividing the address into multiple columns. So this is how the data came in, by the way, because I want to show you third normal form. So I have changed it a little bit. So I have address Bangalore, and then country is India, state is KA, then we have New York, country is USA, state is NY, then you have Chennai, country India, and state is Tamil Nadu. Now there's one more column, DOB_MM_DD, which contains only the month and date of your birth date. Why? Because this is something that would be shown maybe in your profile or in other profiles, and this is something that will be used to send you maybe birthday wishes or some offers. So these 2 tables are in third normal form. What about this one? So customer ID is the primary key, so we'll not talk about customer ID. So let's see name. As you already know, name is completely dependent on customer ID. It is not dependent on anything else. Same is the case with date of birth, because date of birth belongs to the customer ID, and we can have duplicate names. So customer ID is the primary key. Same is the case with email. Address also. Now what about country? Country is also dependent on the customer ID, and state. This is not completely dependent on the customer ID. I think this is dependent on country. And date of birth, MMDD, is actually dependent on date of birth. So let's go a little further and divide this table. So what we see here is that state is actually not dependent on customer ID because state belongs to a country. So state is dependent on a non-key attribute which is country. Same is the case with DOB MMDD. It is not dependent on customer ID, it is dependent on the date of birth. So this table is not in third normal form because 3NF says that no non-key attribute should be dependent on any other non-key attribute. The state column and the DOB underscore MM underscore DD column are violating that. They are violating the 3 normal form definition. So what you have to do? You'll have to create a separate table, or you put country and state, and a separate table for DOB and DOB MMDD. And we'll have to, of course, remove these columns like state and DOB MMDD and put only customer ID, customer name, DOB, email address, country in this table. And this would be the separate table. Now we have broken down this table in 3 different tables. Here country and state would be the primary key. And here date of birth and date of birth MMDD would be the primary key. Here we have customer ID as the primary key. And if we go over these columns, the non-key attributes or non-key columns, in this table none of them are dependent on any other non-key attribute. Here also in this particular table, they are not dependent on any non-key attribute. Same is the case here. So now these 3 tables are also in third normal form. So what we have done, we have taken this particular table which was not in any form. Then we first converted it to first normal form using this, and this is the table which is in first normal form. Then we took the table in first normal form and then converted it to second normal form by breaking them down and using the 2NF definition that the non-key attributes should be completely dependent on the primary key. And this table also, which is the customer table. So this particular table, which was in first normal form, was broken down into 3 tables. Then I extended this table a little bit more and I added few more columns to show you third normal form. And then I broke down that particular table, the customer table, into 3 different tables. And now we have 5 tables from that data and all of them are in 3 normal form. So this is how you take a data, take a business entity and then break them into pieces. So there's a project on data modeling. Please go ahead and do that once the entire data modeling chapter is over.